So this class is statistics, right? What is statistics? When you hear the word statistics, what do you think about? So in this class, what we're going to be looking at is statistics sort of as a field of study, right? So as a field of study, what we're going to be learning in this class is how to collect data, how to organize the data, how to summarize the data, and how to analyze the data. So if you look here at this definition that I have here on the screen, statistics is the science of collecting, organizing, summarizing, and analyzing information to draw conclusions or answer questions. In addition, statistics is about providing a measure of confidence in any conclusions. So that's basically what we're going to be learning this semester in this course. We're going to start off in chapter 1 with what are the appropriate ways of collecting data. And then once we have data collected, we're going to organize it, and we're going to summarize it. By summarize it means we're going to make different kinds of calculations and so on that have some meaning. And then once we've done that, we may analyze that a little bit further so that we can draw conclusions. And it's also going to provide some confidence in how reliable are our conclusions. Are we 99% certain that we're correct? Are we only 70% certain that we're correct? Does that make sense? So there's some reliability involved as well. Now, in this first chapter, I'm going to just kind of apologize. Chapter 1 has a lot of hodgepodge of ideas. There's a lot of terminology and definitions that we have to go through. And so we kind of hop around from topic to topic to topic here at the beginning. After we get through chapter 1, we settle down and we kind of focus a little more clearly, but there's a lot of terminology and stuff that we have to get through first before we can do that, okay? And so, again, chapter 1's kind of a hodgepodge of stuff in order to get us to the point that we're going to be able to focus a little more. So what kind of data is possible to be collected? What kind of information can we obtain? Well, we can obtain information about anything. Statistics is my favorite class to teach because out of all of the math classes I've ever taught, statistics is the most practical in the sense that it actually applies to every field of study. It doesn't matter what your field of study is, you will be affected by statistics. Decisions will be based on statistics. So whether you're the one who's actually doing statistical calculations in your field of study or not, you're going to be affected by statistics, regardless of your field of study. So again, we can gather information about animals, we can gather information about people, we can gather information about plants, we can gather information about rocks, we can gather information about just about anything, whether living, dead, organic, inorganic, or whatever. So another definition, population versus a sample. Population versus a sample. So a population of individuals is the entire group of individuals being studied. So for example, if I wanted to do a study about Lewis and Clark Community College students, and maybe I'm interested in knowing how many credit hours a Lewis and Clark Community College student is taking on average in a semester. Well, if that's the information that I'm trying to obtain, then my population would be all Lewis and Clark students. Now, I'm not sure how many Lewis and Clark students there are this semester, but probably around 3,000 to 4,000 Lewis and Clark students this semester. So the population would be all 3,000 or 4,000 of Lewis and Clark students. Whereas a sample is a subset of the population. So if I were to randomly select, say, 100 Lewis and Clark students, okay, then those 100 Lewis and Clark students would be a sample of Lewis and Clark students. You guys in this class are a sample of Lewis and Clark students. An individual is a person or object that's a member of the population being studied. So each one of you is an individual because each one of you is a Lewis and Clark student. And so again, doesn't have to be people, but it could be people or objects or animals or plants or whatever. Those individuals make up the population or the sample. So we have a graphic here. We got the entire population. A sample is just some of the individuals from that population. An individual is each person, in this case, that's in the population. Now, some more definitions. Parameter versus statistic. A parameter is a numerical summary of a population. Now, what on earth does that mean? A numerical summary of the population. Well, a numerical summary generally is going to mean some kind of a computation, some kind of a calculation. So like an average. An average is a numerical summary. It may just be a count. In statistics, we call a count usually a frequency. So a count. So like if I wanted to know like how many Lewis and Clark students are taking at least a full load of classes, like a full-time student, I could count those. So of say the 3,000 or 4,000 Lewis and Clark students, maybe 2,500 of them are full-time. So that 2,500 in that sense would be a numerical summary. So since that's out of the entire population, that would be a parameter. Now, on the other hand, a statistic is a numerical summary of a sample. So if I have a sample from the population and I have an average or a count or something like that from the sample, then that isn't a parameter, that's a statistic. So if I randomly selected 100 students, and if 70 of those 100 students are full-time, then 70 would be a statistic. So our goal in this class ultimately is to be able to figure out how to use statistics to predict parameters. Because most of the time, in most scenarios, it's not really going to be physically possible, or at least not practical, to figure out what the true parameter of a population is. Now, with Lewis and Clark students, I could get information about every Lewis and Clark student probably, and I could calculate parameters for Lewis and Clark students because the population's not that big. And the information's already probably in a database. But if I wanted information for every community college student in the United States, so my population now just expanded to be all community college students in the United States. Obtaining information about every individual in that group is going to be nearly impossible. So it's impossible for me to really find the true parameter. So instead, what we do is we take samples. I take a sample of community college students in the United States, and I would obtain the information from the sample. And then what we're ultimately going to do is learn how to use the information from the sample to estimate or predict what's true about the entire population. And can we supply some level of confidence that what we're concluding about the population's accurate? So that's what we're heading for eventually. So what I'm getting at is there's really sort of two broad branches in statistics. There's descriptive statistics and there is inferential statistics, okay? So descriptive statistics basically means just exactly what the word says. It's statistics that are describing the sample. So like when we find a calculation, like a percentage or an average or something like that, that is a descriptive statistic. So a descriptive statistic consists of organizing and summarizing data. Descriptive statistics describe data through numerical summaries, tables, and graphs. So again, when we do calculations like finding an average, that would be a descriptive statistic. If we organize our data into a table, that's descriptive statistics. If we create a graph, that is descriptive statistics. We're using it to describe what the data sort of looks like, to summarize it. as opposed to inferential statistics. Inferential statistics uses methods that take the results from a sample, extend it to the population, and measure the reliability of the result. So again, that's really our ultimate goal. This is what we'll be doing about the second half of the semester. The first half of the semester will be primarily dealing with descriptive statistics, and then we'll switch and look at inferential statistics, and again, how we can use the information from a sample to predict what's true about the entire population. And the cool thing is that we can do that fairly reliably if we use the correct processes. So we have our first example. So determine whether the underlined value is a parameter or a statistic. So part A, only 12 men have walked on the moon. The average time these men spent on the moon's surface was 43.92 hours. So we're looking at this underlying value, 43.92 hours. And the question is that a parameter or is that a statistic? In this case, we have a very, very small population. There's only 12 people who've ever walked on the moon, right? And so if you average the amount of time those 12 people spent on the moon, it's 43.92 hours. That's because that's calculated from the entire population, that's a parameter. Now, part B, a sample of 500 students finds that 68% own a car. Parameter or a statistic? So in this case, we're just looking at a sample, not the whole population. So of these 500, 68% own a car. And so that is a statistic. So again, really our ultimate goal in this class is to be able to use statistics to predict parameters. And we want to be able to do that with reliability. And it's not extremely difficult to do, but it does require a little bit of effort to be able to do it reliably, okay? And so that's where we're going to be heading as we go through this class. Next. Again, in this section, in this chapter, we kind of hop around from idea to idea. So the next thing that we're going to discuss is the process of statistics. And this is just kind of the concept of how we go about doing a statistical study. If we're going to do a statistical study, there's a process that we need to follow. This is really kind of the same as any scientific process, just sort of the steps that you go through. So the first thing that we have to do is we have to have a purpose, right? So we identify the research objective. If we're going to do a statistical study, I mean, really step one is, what's the purpose? So a researcher must determine the questions he or she wants answered. The questions must clearly identify the population that's to be studied. So again, we have a research objective. So if my objective is to figure out what proportion of Lewis and Clark students are full-time students, then that would be my objective. That's my question. Step two, once we have the objective established, we need to collect the data that we're going to need to be able to achieve that objective. So if we've asked questions that we want to answer, then we're going to need to collect the data that's going to be required to answer those questions. So again, typically this will involve sampling rather than being able to get information from the entire population. So almost always we will use samples of data rather than the entire population of data. Now we'll talk through, as we go through this class, there's appropriate and inappropriate ways of collecting data. To get reliable results, we need to collect the data appropriately. And so we'll actually be talking about that a little bit later in chapter 1. Step 3, once we have the data collected, we're going to describe the data. So this may mean that we're going to organize it like in a table. We may create graphs. We may do numerical summaries like calculating averages or proportions and so on. So that's the descriptive aspect of statistics. And so we'll start looking at descriptive statistics in chapters 2, 3, and 4. We'll be dealing with descriptive statistics. And then step 4, we will perform inference. So once we have the descriptive statistics, again, from a sample, we're going to want to try to generalize that to the entire population. Okay, so we're going to be dealing with inference, and we'll be dealing with inference around the second half of the semester or so. So basically, with the collection of data, we're going to do that in chapter 1. Describing data, we're going to be doing that in chapters 2, 3, and 4. Inferential statistics really starts around chapter 9, and the chapters in between, so chapters 5, 6, 7, and 8, are going to be, I guess, more related to inferential statistics, but it's kind of the underlying math that we need in order to be able to do the inferential statistics. So we have to like build the tools to be able to do the inferential statistics, and that's what's going on in the middle. Now, this isn't the normal kind of example, but just take a look at this example here about the statistical process. Pew Research conducted a poll and asked, quote, "Do you trust all or most of your neighbors?" The following process allowed the researchers to conduct their study. So this is Pew Research. They're wanting to know, do you trust your neighbors? And so this is the process they followed to be able to answer that question. So the first thing, identify the research objective. The researchers wanted to determine the percentage of adult Americans who trust all or most of their neighbors. So that's their question, right? That's the question they're trying to answer. That's the objective. So second, they had to collect the data they needed to be able to answer that question. So the population in this case was all adult Americans, but it would be unreasonable to try to actually find the true parameter because there's over 200 million adult Americans. So instead, the researchers surveyed a sample of 1,628 adult Americans. Of those 1,628 adult Americans, 847 stated that they trust all or most of their neighbors. So they've obtained the data. So basically, they took 1,628 adult Americans and said, do you trust your neighbors or not? And so of those, 847 said yes, and the rest, I assume, said no. Now, so describe the data. Well, in this particular case, we could convert that to a percentage. Probably would be a little better description than just the raw numbers. So if we take 847 and divide by 1,628 and change that to a percent, that's about 52%. So 52% stated that they trust all or most of their neighbors. Now that 52% in this case is a statistic because it's only from the sample, not from the entire population. So we know the statistic is 52%. We don't know the true parameter. Now, so the last step is perform inference. Well, Pew researchers wanted to extend the results of the survey to all adult Americans. When generalizing results from a sample to a population, the results are uncertain. To account for this uncertainty, Pew reported a 2.5% margin of error. Now, you've probably, if you've ever paid attention to political polls or anything like that, you've probably seen margins of errors before. So it's pretty common to have a 2.5% margin of error or a 3% margin of error or something like that. So basically what that means is this 52% that we found in this sample is probably no more than 2.5 percentage points away from the true parameter. So if we take 52 and subtract 2.5, we get 49.5%. If we take 52 and add 2.5, that's 54.5%. So probably the true proportion of Americans that trust all or most of their neighbors is probably somewhere between 49.5% and 54.5%. It's probably not exactly 52%, right? But it's probably in that range. So that's the idea of inferential statistics, and we'll learn how to do that at the end of the course.